So in Millfork, been carrying on a bit, and now I have the 64 version is now complete, effectively. I added all the correct modes, and we just fire it up. I didn't prepare it this time because I discovered last time it having all the emulators running pushes my fans up, obviously. That loads. I also tried the optimization mode, cranked the optimization up. Took out about half a K. Not too bad. Now we got the title screen, and I can move it. There's water, and there's a well done screen. Pretty much all of it. I did run into a couple of interesting cases. I had to crank out the ASM. You can't do a divide on a 24-bit value. No long division. So I had to copy in some ASM, which it's nice. It was a good test. Nice to see how easy it goes in. It's a very simple assembler though. Nothing too fancy, but it's nice that it can reference the outside world. So it's kind of like inlining in GCC, I suppose. Where's this big? Yeah, the dispatch. So we have this return to at cause, which is basically a function pointer table lookup. It caused me a lot of pain, thanks to MonstersGoBoom figured out you need to put a return false at the end. Otherwise, you just get an error message that says this doesn't return anything, when it clearly has a return in it. That's all it did. That was a fun night, thanks to Monsters, who was able to figure this one out, get past it. Apart from that, it was pretty straightforward. I eventually figured out how to do the text. You put it in an array as different entries, and then it just so happens that they're all in memory byte after byte. So you can just treat this as one long string, because there's no way to do multi-strings as far as I could tell. Another fun thing was when you pull in a file, the last entry, the entries here, they can't do maths. So if I made this 5 times 40 or 6 times 40 or whatever they are, then it just fails. You can't do maths in them. I've raised a bug for it though. That's a bit silly. Monsters also pointed out to me that my poke problem was a bit stupid, and I could have just, you just put a byte at it, and then you can just assign it instead of doing the pokes. Stop being lazy. I mean, it's a fair call. Can't argue. So I then decided to look at, make sure it still works under full optimizations, make sure it doesn't break anything. It didn't, as far as I can tell, which is good. But the optimization, this case here, so here's the actual code. The parallel onto 0 upwards just copies, right? So we load 24, store it into a variable. We decrement the variable. We load that variable into Y. We index into it. We store with it. Then we load that variable back, and then we branch if it's not equal to 0. Yeah. That's not too good. And then we get down further. There's another one down further. Where is it? Oh. So here it kind of looks like it's doing a good job. We LDY with 8. We DEY, so we don't store it in anything. We keep it in a register. We load, we store. We do a TYA in a branch. Not great. Oh, that does remind me, there's one other thing about the assembly I didn't like. It doesn't let you do the correct form with putting an A. It doesn't allow A's after rolls and LSRs and things. It requires without the A. And that's worse than the way it forces the brackets. Terrible. But I mean, to be fair with the optimization, it doesn't do it inside a function. It doesn't have inside function overlaps, but between functions it can reassign variables to memory locations. Just go down to and here. We should see. That's not good. Where's the other one? So there's a bunch of things that are assigned to 4.3, for example. Which they don't overlap, and a bunch of 4.5s, and a bunch of 4.7s, and a bunch of 4.Bs, etc. So that's nice. Solves those problems. Oh, there was another thing I found as well. Where was it? And this one's kind of a tricky one. Okay, so up here we have zeros. So these both get stored as a 0. And then I do this, and this, and this, and this, and this, and then we have another 0. So on one hand, you kind of want it, sometimes you do want it to reorder things for optimality. If, for example, you could make this an X, store X, and then get the 1, you could do an I in X, save to byte, and then do an STX, and then STX. But then other times you don't want it to rearrange. I solved this in MLA by having groups, and everything was bolted together without any space between it. It would reorder, and anything it couldn't reorder across groups. But I'm not sure how you could do this in this. Maybe you could wrap it in brackets, something. But yeah, I'm not really overly impressed with the optimization skills. I mean, something like a simple for loop really shouldn't be that much of a problem for it. Yeah, it is quick to code in, though. I have to give it that. It's very quick to code in. And I'm sure it's probably better than C65. So once I had the 64 version working, I then downloaded the 65 version and started working on the 65 version. Oh, that was fun. So I copied it just so we have a new thing. Spent ages, and thanks to Shallan and MonstersGoBoom, we were able to eventually get a sprite working. The main problem was I foolishly believed that the sort of next stable version would at least be able to handle a Commodore 64 sprite. I was wrong. You have to use the older VIC-4 special custom other version to get a C64 sprite. Some other fun things, you have to enable the M65 default mem, because when Basic access it, you don't have the default memory map for some reason. And I had to add this, which is not in Monsters macros. So let me just... What is zoom in this? This is... Just zoom this up so it's nice and clear depending on what your resolution is. Yeah, you want to put this in your code. If I take this out, the sprite just doesn't work. It stuffs up completely, just disappears. Put it in, my sprite works. Fun times. Is that too small? No, that looks fine. I'll leave it over there. So yeah, I eventually end up switching to the VIC-4 style, so you can have 16-bit pointers, and trying to do all different types, fully setting all the registers. The order of doing this turned out to be important. We had to change the order of this around and the order that we set things in. But kind of, that was sort of it. Just doing the startup, rearranging the memory map, and working out this magic, which took quite a while. I have a bat file. Oh, and he uses the Java version. It takes so much longer to work. The Windows version is so much better. Java version just takes a lot longer. But here we are on the Mega65. This down here is actually normal. You just can't see it on the 64 version because I shrink the screen, but that doesn't work on a 65. Do I have to swap the joystick in this one? No. And there it is. Isn't it pretty? The stuff at the top of the sprite, because I've moved the sprite around so it's not being cleared, whereas before it would have been. I'm not worried about it because I'm going to completely get rid of most of this. You can kind of see stuff. See, the numbers are perfect, so my ROM copy routine does actually work. Just for some reason it doesn't for all of it, and clearly it does not support ECBM. But see, if you do this, you can see the water. And it moves. And you get the well done screen. And the next level. So that works. And now I'm going to look at converting the 1:8 graphics into Mega65 graphics. Another Python script converter. Yay. So sick of writing those. And then look at trying to get this working in the bitmap mode. Which, given how much fun the Mega65 emulator is, I'm sure it's going to work perfectly fine. But deadline's coming up, so I'm not sure how much I'm going to be pushing extra into it, but hopefully I can still make it. Join me next time.